Hello and welcome to another video on linear programming. Today we're going to be looking at blending models. Let's get right into it. Example 1. A chocolate company currently sells 3 bars of chocolate. Milk Chocolate Swirl, Milk Chocolate and Nuts, and Milk Chocolate Dream. The company has 10 pounds of chocolate, 2 pounds of caramel, and 4 pounds of nuts. The Milk Chocolate Swirl contains at least 90% chocolate and has 0% nuts. Milk Chocolate and Nuts must contain at least 20% nuts. The Milk Chocolate Dream must contain at least 10% caramel and 10% nuts. The Milk Chocolate Swirl sells for 30 cents per ounce. The Milk Chocolate and Nuts sells for 40 cents per ounce. And the Milk Chocolate Dream sells for 55 cents per ounce. Formulate an LP to maximize the revenue of the chocolate. So right off the bat, we're going to start with our objective function. See in that last sentence, it's to maximize the revenue. And it's set revenue equal to Z, and we're going to define Z later, after our decision variables. So here's our decision variable. We know that we have to keep track of 2 separate things in our decision variable. We know that we need to keep track of our ingredients, and we know that we need to keep track of our products, right? Because we know we have swirl, we have and nuts, and we have Milk Chocolate Dream. And in our ingredients, we have chocolate, we have nuts, and we have caramel. So we're going to have to keep track of both of these, and we can set this up in our decision variable. Erase that real quick. Our decision variable down here can actually be set up as xij. This is a decision variable with 2 indexes. So this is going to represent the ounces of ingredient I in product j. Of course, I is going to equal 1, 2, 3, and j is going to equal 1, 2, 3 as well. So we can see that this is actually going to be our I right here, and this is going to be our j. So 2, 3, 1, 2, 3. So in just brief terms, x11 is going to represent the ounces of chocolate in the Milk Chocolate Swirl. X12 is going to be ounces of chocolate in Milk Chocolate and Nuts, and X13 is going to be the ounces of chocolate in Milk Chocolate Dream. We're just going to erase that, but that's how we're going to explain that. So now that we have our 2-index decision variable, we're going to go back to define Z. So we know that 30 cents per ounce, and we want to know the amount of ounces, or we want to know the amount of product 1 that is sold. So we have the amount of chocolate in product 1, plus the amount of nuts in product 1, plus the amount of caramel in product 1. That equals the total ounces sold. Multiply that by 30, giving you the revenue for your chocolate swirl. Now we have our 40 times the amount of chocolate in your Milk Chocolate and Nuts, plus the ounces of nuts in Milk Chocolate and Nuts, plus the ounces of caramel in Milk Chocolate and Nuts. So that's going to give you your total ounces of product in Milk Chocolate and Nuts multiplied by 40 cents per ounce. And we have 55 being x13, x23, and x33. Total amount of product or ingredients used to make product 3 multiplied by that 55 cents per ounce. Now we're going to have to start with some constraints, and these are a little tricky, so we'll go through. And we'll have our subject 2. I'm going to write over here on the side. We know that the amount of chocolate in the swirl has to be greater than 0.9. But this is going to give you a percentage or a ratio. So you would think this. Well, this is incorrect. You need to have your ounces of chocolate over your total ounces of product. Total ounces of product. So this is actually going to be reflected by x11 over x11 plus x21 plus x31. This is your ounces of chocolate over your total ounces of product. And then in order to shorten this and get rid of that fraction, we're going to come over here now that we've explained this, and we're going to have our swirl chocolate constraint. So swirl choc. We're going to have that 0. or x11, so the ounces of chocolate has to be, has to be greater than or equal to 0.9 times the total amount. Then we're going to have the amount of nuts and nuts constraint. This is going to be total number of nuts in product 2 must be greater than 0.2 times the amount of chocolate in product 2 times the amount of nuts in product 2 plus the amount of caramel in product 2. And then we're actually going to have 2 constraints for the dream chocolate, so dream nuts. The amount of ingredient 2, the amount of nuts in product 3 has to be greater than 0.1 times the total product, or the total ounces in that product. And we need to know that dream caramel, the total that product, so the total caramel product 3 has to be greater than 0.1 times the total product itself. And also we need to come back and we need to define the 0% nuts. So the swirl nuts constraint equals the amount of product 2 in 1 has to equal 0. So there can be 0 ounces in product 1. So 0 nuts in product 1. Now we need to go through and get the revenue per ounce. We know that we have 10 pounds. We know that we have, that's 10 pounds of chocolate, 4 pounds of nuts, and 2 pounds of caramel. We also know that there are 16 ounces in a pound, so we need to multiply this, 16. The way we're going to do that is ounces per pound, and ounces per pound. This is going to get rid of your pound on the bottom, and this is going to get rid of your pounds over here. So we know we have 160 ounces of chocolate. We know that we have 64 ounces of nuts. And we have 32 ounces of caramel. And now we need to come down and do this little inventory. So our inventories are going to be total amount of chocolate in each product has to be less than 160. The total amount of nuts in every single product has to be less than 64. The total amount of caramel in every single product has to be less than or equal to 32. These are our inventory, or at least that's what I'll call it. And of course we need our non-negativity. states that xij has to be greater than or equal to 0 for I equaling 1 through 3 and j equaling 1 through 3. It's a little tricky, but hopefully this video was helpful, and we're going to do a couple more examples.